Hello everyone, this is Mr. Molepo JB presenting the lesson today. So, on today's lesson, we are going to focus on mathematics, paper 1. So, today we are going to do 4 sub-questions regarding this paper 1. And by solving these questions on this paper, for preparing for our final examinations or preparing for the upcoming test. So, we are going to deal with we're going to do algebra, number patterns, and functions, then conclude by calculus question. So we're going to start with our question 1. On question 1, we are going to deal with algebra. So here we're given a function. They say f at x is equal to x squared minus 3x into 3x minus 1 plus 2, right? So they say solve for x if f at x is equal to 0. So on 1.1.1 they say x is an integer. So we have to solve for x if x is an integer, right? So they say f at x is equal to 0, meaning we have to equate our function to 0. We'll have x squared minus 3 into 3x minus 1 into x plus 2 equal to 0, because they say f at x is equal to 0 and our f at x is this. We equate it to 0. So we know that if we have 3 or 2 brackets or more multiplying each other equated to 0, we can simply say each bracket is equal to 0. We can say x squared minus 3 is equal to 0, or 3x minus 1 is equal to 0, or we can say x plus 2 is also equal to 0. Then we have to solve each x separately. So this side we are going to have x is equal to -2. By taking our 2 to the other side, we will change our sign to -2. Therefore, for this side, we have 3x minus 1 is equal to 0. We can move 1 to this side, so we have positive 1. Then we divide by 3 since we are looking for x, not 3x. Therefore, this and this will cancel out. We will have x is equal to 1 over 3 as our second x. Then for this side, we have x squared is equal to 3. By moving this 3 to this side, it changes its sign. Therefore, we'll have to remove this squared by what? By a root. When we apply a root on x squared, we're going to have x is equal to plus or minus root 3, meaning we have two solutions as positive and negative root of 3. So therefore, they say when x is an integer, remember an integer cannot be what? Cannot be equal to be a fraction or a decimal number. So meaning our first x plus or minus 3 is what? Is a decimal, so it won't apply. Then our second x is what? Is a fraction. Then our third x is equal to -2, which will apply. So therefore, our x will be equal to -2. Then we move to 1.1.2, which says x is a rational number. A rational number can be a fraction, or a ratio. So we have to check if we have a fraction or a ratio here. Then if we check, we have x is equal to 1 over 3 as our first x, since it's a fraction. Then as x is equal to plus or minus root 3 won't apply to our solution because it's not a fraction or it's not a ratio. Ratio, you can say 1 is to 2 or 2 is to 1. So here, then our third x is equal to -2, which can be a ratio. You can say x is equal to -2. So we are done with 1.1.2. Move to 1.1.3, it says x is a real number. When they say x is a real number, it means all our x's we found here are what? Are real numbers. So we're gonna have x equal to root 3, or x is equal to 1 over 3, or x is equal to -2. So we move to 1.2. 1.2 says solve for x given that, sorry, given that -15, given that, sorry, says solve for x given that -15 minus 9 plus 4 is equal to 0. You see, correct the two decimal places. By this they mean you should use quadratic formula, and then you must correct or round to two decimal. So here we have -15 minus 9x plus 4. So we're going to use our quadratic formula, which states that x is equal to -b plus or minus root of b squared minus 4ac divided by 2a. So we're gonna name our a and b's on our equation there. So we know that a is a number that multiplies what? X squared. So we're gonna have a here, then b is a number that multiplies a, it's a coefficient of x. So we're gonna have b, then c is our constant value, which is 4. Therefore, we're going to substitute by saying negative into negative b. Remember, it's -9, not +9. You must never make that mistake. When you multiply, you open a bracket so that it will change our signs there. Then we go into and then b squared is equal to -9 squared minus 4. Our a is -15. Then our c is 4. All divided by 2 of -515. So x is equal to, when you press our calculator, we press the positive sign first, then after the negative sign first. So when you press both signs separately, our x will give us -0.900, or x will be equal to 0.30. And then we are done with 1.2.1. Then we move to 1.2.2. On 1.2.2, it's a inequality indicated by this sign. We notice that this is an inequality. So we have to check how can we solve x here. So what we've noticed so far is that this bracket is squared, meaning there are two brackets here. We can simply say 3x minus 2 into 3x minus 2 is greater or equal to 3x. This indicates that our brackets are 2. If there was 3, we're going to multiply 3 brackets. Therefore, we have to multiply both these brackets by the rules of Bottom's brackets off. So here we have 3x multiplied by 3x is going to be 9x squared. 3x multiplied by -2 is going to be -6x. Then -2 multiplied by 3x, it's going to have -6x. Then -2 multiplied by -2, it's going to have what? +4, greater or equal to 3x. Then we'll have to move this 3 to this side, or we can simply simplify our left hand side first. This is what? -12x plus 4. Then we move this 3 to what? To this side, it's going to be -3x is greater or equal to 0. So we have to group them by our like terms. It's going to have -9x squared minus 3x minus 12x plus 4. It's greater or equal to what? 0. So when we get here, we can use factorization by grouping. We can group the first two and group the second two. So when we group the first two, we have to factorize the first two, which says 9x squared minus 3x. We have a common factor of 3x into what? When we take out 3x here, we're going to be left with what? 3x. Then this side, when you take out 3x, we're going to have what? -1. Therefore, we go this side. This side, we pick this sign before doing anything. We put our negative there. Then we have to find our factor, common factor there, which is what? 4. 4 it's here, it's in here, and 4 it's here. So we're gonna put 4 into, when we take out 4 this side, we're gonna be left with 3x. Remember, we took out negative 4, not positive 4. So it's going to be what? Positive this side. So that negative times positive gives out negative. Then here, we are gonna be left with 1, negative 1. Because negative times negative is gonna be positive, so greater than 0. So when we get here, we can simply see that our two brackets are equal or are the same. So we're gonna pick only one. We can say 3x minus 1. Then we add our second bracket by taking this and this to be our bracket. We can say 3x minus 4 to be our bracket. So from there, we are gonna say this you can see that this is multiplying this and they equate to 0. So we can say the first bracket is equal to 0, the second bracket is equal to 0. So we can say 3x minus 1 is equal to 0, or 3x minus 4 is equal to 0. So here we have 3x is equal to, by taking this one to this side, it's going to be 1, or 3x is equal to 4. Therefore, here we're going to have x is equal to 1 over 3, or x is equal to 4 over 3. Therefore, these are not our exact x values we are looking for. We call them our critical values. Therefore, we're going to notice that x is less or equal to 1 over 3, or x is greater or equal to 4 over 3. Then you are done with 1.2.2. We move to 1.2.3. On 1.2.3, it's an exponential equation. So exponential equation, we can see that our power or our exponent is what? It's a variable that we are looking for. So firstly here we have to multiply this positive 5 into the bracket. So we'll have 5 to the power of x is equal to 5 multiplied by 4, it's 20. 5 multiplied by 5 to the power 2 minus x, it's going to be plus 5 multiplied by 5 to the power of 2 minus x. So from here we can say 5 to the power of x is equal to 20. We change this side. Remember, if we have the base, that's the same base, we can do what? And we're multiplying, we add what? Exponents. We can say 5 to the power 1 plus 2 minus x. So we're going to have 5 to the power of x is equal to 20 plus 5 to the power of 1 plus 2 is 3 minus x. So here we know that we can say 5 to the power of x equal to 20. We can change 5 to the power of 3 to 125. Then 5 to the power of negative x by what? 5 over x. We can change to our negative to positive by including our division sign. Then we can let 5 to the power of x to be equal to 8 to see our equation clearly. So we can say a is equal to 20 plus 125 divided by a. So when we are here, we can simply multiply by our LCD both on the left and the right hand side. We can say a multiplied by a is what? It's a squared is equal to 20 multiplied by a is 20a. Then 125 over a divided by multiplied by a, it's gonna be what? 125. Then we move to this side. So when we move to this side, we are gonna have a squared. We take 20 to the other side, it's gonna be negative 20a. Even 125 is gonna be negative 125 is equal to 0. So when you are here, you have to do what? Brackets by looking for factors of 125, which we can add or minus, they will give us negative 20. So our factors will be 5 multiplied by 25 will give us what? Negative 125. So for our answer to be negative, we have to include negative in one of these factors here. But then we have to check by looking at what our b, meaning it had to be negative 20. For our b to be negative 20, we have to be what? Positive 5 minus negative 25. So we're going to say a plus 5 and a minus 25 to be equal to what? 0. So we simply know that if the brackets are multiplying each other, then they are equated to 0. We can say a first bracket equal to 0 or the second bracket to be equal to 0. So here we know that a is equal to what? Negative 5, or a is equal to positive 25. Then we notice that a is equal to what? 5 to the power of x, as we have learned before, or a 5 to the power of x equal to 25. So here we must change our bases to be what? The same, so that we can drop our exponents. So by looking here, we have negative 5, which means we can never change negative 5 to be what? Positive 5. So we have what? No solution here. Or this side, we can say 5 to the power of x. We can change base 25 to what? 5 to the power of 2. Then we know that 5 to the power of 2 is the same as 25. So since the bases are the same, we drop what? Our exponents. So we're simply going to say x is equal to what? 2. Then we are done. Then we move to 1.3 to solve for x and y. This is the smartiness question. Solve for x and y. X and y, that log of x to the log of x 16 is equal to what? 4, and y plus root of x plus 7 is equal to x plus 1, given that x must be equal or greater than 0. So firstly, we're going to have equation number 1, then this will be equation number 2. So we have to create equation number 3 by equation number 1 or equation number 2. So we're going to use equation number 1 since it's the simplest. We are going to say this is the same as 4 to the power of x is equal to 16. 4 to the power of x is equal to what? 16. So we're going to have 4 to the power of x. We can change 16 to what? To base 4 to the power of 2, because 4 to the power of 2 is equal to 16. Since we have the same basis, we can say x is equal to 2. Then you see that x is greater than 0, which means our answer here must be what? Precisely correct. Therefore, when we're looking for y, I can say y plus x plus 7 is equal to x plus 1. Therefore, we can change our x here by substituting our x value, which is 2. We can say y plus root of 2 plus 7 is equal to 2 plus 1. This side will have positive 3, then y plus root 9. So we know that root 9 is the same as what? That's 3 is equal to 3. Then if we're looking for y, we have to change this 3 to the other side. It's going to be y is equal to 3 minus 3. Y is equal to 0. Therefore, we can conclude by x is equal to 2 and y is equal to 0. Then we are done with 1.3. We go to 1.4. It says calculate the two numerical values for p so that x squared p plus x squared plus p into 2x plus 7 plus 8 is a perfect square. So we can say that x squared plus p into 2x plus 7 plus 8 is a perfect day. So we're simply gonna do what? Simplify our bracket first. So we're gonna have x squared plus p plus, or we have to multiply this side. So p multiplied by 2x is gonna be what? 2. We're gonna have 2xp. Then p multiplied by 7 is what? Plus 7p plus 8. So this is the same as x squared plus 2xp plus 7p minus 8. So we're going to complete our square now by saying x squared plus 2xp plus p squared minus p squared plus 7p minus 8. So here we will notice that this bracket is the same as x p plus p being what? Squared is the same as this bracket minus p squared plus 2p minus 8. Therefore, here we can say we have completed what? Our square. Completed our square. Therefore, we can say that therefore 0 is equal to negative p squared minus 2p minus 8. So we can simply take these things to the what? To the other side. We're gonna have p squared minus 2p minus 8. So here we can equate it to what? To 0. So here we can factorize this by saying by the factors of 8, which is 7 and 1, we can say must be p plus 1 multiplied by p minus 8 is equal to 0. Remember that if we say 1 multiplied by negative 8, it's going to be give us what? Negative 8. And when we say this is 7p, sorry, this is 7p. My handwriting is not that good. This is 7p. So we know that 1 minus 8, it's going to be what? Negative 7. So it's going to be, then we see that the two brackets are multiplying each other. We can simply equate this bracket to 0 and this bracket to 0. So our first p will be p is equal to negative 1 or p is equal to 8. Then we move. So we are done with algebra so far. We move to question number 2, which is our number pattern. We call this a number patterns. So by number patterns, so they say the following sequences of number forms a quadratic pattern number. This is a quadratic sequence. We know that in quadratic sequence we might have two differences. So we're gonna have negative 3 into negative 2, negative 3, negative 6, negative 11. So to find our first difference, we're gonna say T2 minus T1 is equal to D. This is how we find our difference. So we're gonna say negative 2 minus into minus 3, it's gonna be negative 2 minus into minus 3, it's gonna be positive 1. Then we're gonna say negative 3 minus into minus 2, it's gonna be negative 1. Then here we're gonna say negative 6 minus into minus 3, it's gonna be give us negative 3. Then here we're gonna say negative 11 minus into minus 6, is gonna give us negative 5. So this is our first difference. Then we have to look for the second difference. Same thing by T2 minus T1, it's gonna give us our D. So here we're gonna say 1 minus 1, negative 1 minus 1, it's gonna give us what? Negative 2. Then negative 3 minus into minus 1, it's gonna give us what? Negative 2. Then negative 5 minus into minus 3, it's gonna give us what? Negative 2. This is our D2. So they say 2.1, the first differences of the given sequence also form a sequence. They say this, it forms what? A sequence, which means it's gonna be it's gonna be 1, negative 1, negative 3, and negative 5. So here we will notice that our difference is what? Negative 2, since we already calculated. So whenever we have a sequence like this, which our D is all the same, D is to our difference is equal, we're gonna notice that this is what? An arithmetic sequence. We're gonna have A plus B into n minus 1. This is what? Arithmetic sequence. So they say determine an expression for the nth term of the first difference, meaning they want the general formula for what? The first difference. So we're gonna A is our what? Our first term. Then D is our difference. Since it's equal all over, we're gonna have T of n is equal to our first term is what? Positive 1 plus our difference is what? Negative 2 into n minus 1. So here we're gonna say 1, gonna say 1 minus 2 into n minus 1. So this is the same as 1 minus, we multiply our 2 into our bracket, it's going to be negative 2n minus, I mean positive, because negative times positive, negative is what? It's going to be positive. Then here we will go negative 2n, 1 plus 2 is going to be what? Positive 3. This is our 2n. Then we're done with 2.1, we move to 2.2. It says calculate the first difference between the 36, 35 and 36 of the quadratic sequence. So we're going to use what? Term number 35 to get our difference. So this is the same as negative 2n plus 3, which will give us what? Remember, our n now is what? Equal to what? 35. It's going to be negative 2 into 35 plus 3, which is going to give us negative 2 multiplied by 35, which is going to give us negative 67. So our answer here is what? Negative 67. Therefore, we move to 2.3. It says determine the expression of the n term of the quadratic sequence. We know that quadratic sequence is the same as an squared plus bn plus c. So to calculate the value of a, we know that a is equal to difference number 2 divided by 2, which our difference number 2 is going to be what? Negative 2 divided by 2, which is going to be equal to negative 1. Then b is calculated by d1 minus 3a. This is our formula, guys. So d1 is going to be what? Positive 1 minus, remember, we have our first difference here, which is what? Negative, it's going to be positive 1. This is our first difference. We pick the first value. When you say d1, you pick the first value. So we're going to have 1 as our d1 minus 3 into our 8, what? Negative 1, because we calculated. So this is the same as 1 negative times negative is going to be what? Positive 4. This, I mean positive 3, sorry, positive 3. This is going to give us what? 4. Then for c, we have to say t1 minus a minus b. So this is our first term, which is given by negative 3 minus into minus 1, because our a is negative, minus 4. So this is the same as negative 3 plus 1 minus 4, which will give us negative 3 plus 1 minus 4 is going to give us negative 6. So we're going to substitute our values here. We can say Tn is equal to our a is what? Negative 1 n squared plus our b is what? 4n plus our c is what? Negative 6. So we're going to say Tn is equal to negative n squared plus 4n minus 6. Then for 2.3, we are done. So they say explain why the sequence will never contain a positive term. So firstly, we're going to check if our turning points, what are our turning points. So when we calculate our turning points, we will see that our turning points are negative 2 and 2, whereby we will notice that our sequence cannot be positive since our turning point since our turning point is above the x-axis. So we're done with question 2. We cannot do question 3 because it's the same as number patterns. We move to question number 4. Question number 4 is what? A function. We say these are functions. So here they say the graph of f is equal to a over x plus p. Then we know that this is our x asymptote, this is our y asymptote. easy, and h at x is equal to mx plus c as guessed below. So we have to check what do we know about our graph. So we notice that this point is what, negative 2 and negative 1. Since our x is what, negative 2, then our y is negative 1. Then this for it on this point we know that f at x is equal to h at x, since it's a point of what, intersection of the two graphs. Even here we know that f at x is equal to h at x. This is our origin, we know that is 0. So we move. They say write down the values of p and q. Remember, p is what, our x asymptote, but then it's written as negative, meaning we are gonna take our answers what, as positive. We're gonna have positive 2. Then our q, it's what, negative 1. Doesn't change any sign. So they say calculate the value of b of a. Remember, f at x is now equal to what, a over x plus p plus 2, plus 2 minus 1. So we're gonna pick a number. We're gonna pick coordinates that are what, included on that point. We have negative 4 and negative 5 over 2. They lie on our graph of what, of f. This is graph of f at x. So our points lie on what, that. So we're gonna pick them. This is x, this is our y. So we're going to substitute y where we see what, y, then x where we see what, x. So we're gonna have negative 5 over 2, that's our y, to be equal to a over our x is negative 4 plus 2 minus 1. So we're gonna take this negative 1 to this side. It's gonna be negative 5 over 2 plus 1. It's gonna be equal to a over negative 4 plus 2. It's gonna be 2 minus 4. It's what, negative 2. So here we're gonna have negative 5 over 2 plus 1, which will give us negative plus 1. It's gonna give us negative 3 over 2. This is the same, is equal to a over negative 2. So we're gonna simply multiply by cross multiplication. We're gonna say a multiplied by 2, it's gonna be 2a. It's gonna then equal to negative 3 multiplying by negative 2, it's gonna be what, positive 6. So if we're looking for a, we have to divide both sides by what, 2. Meaning here if we divide by 2, it's gonna have a. Then if we divide 6 by 2, we're gonna have what, 3. Therefore a is equal to positive 3. Then they say write down the range of f. The range of f is our the graph that we've been solving. So we notice that on our graph f, on graph f, all the y values are included, because we can see that from positive y values, there is an infinity sign there, which means that our graph, all the y values are included on the positive side. And on this side also, we have what, a negative infinity sign, which says all y values are included. But then we have an asymptote of what, negative 1. So we are gonna say, we are going to say y is the element of all real numbers, but y must not be equal to what, negative 1, since negative 1 is our what, asymptote. So y cannot be equal to negative 1. So we move to 4.4. It says determine the equation of the line of symmetry for m is less than 0 in the form of, we know that axis of symmetry is what, mx plus c, right? So they say m is less than 0, simply saying m is what, is a negative. So we're gonna say y is equal to negative x plus c. So far, if we notice that our axis of our line of symmetry here is our graph of h, this is h at x, we notice that is our axis of symmetry for this graph. So how do we find c? We can find c by what? By picking a point that lies on the graph, which is negative 2, and negative 1, which lies on our graph of h at x. So we're gonna pick what, negative 2 and negative 1. So we're going to have negative 1 this side is equal to negative into negative 2 plus x. We're just going to have negative 1 is equal to positive 2 plus c, then negative 1 minus 2 is going to be what, c. Therefore, y is equal to negative x, then our c is what, negative 1 minus 1 is the same as what, negative 3. Therefore, our graph, they say we should give it in the form of y is equal to something, so it's going to be negative x minus 3. Then we move to 4.5. It says write down the equation of the asymptote of f at x. So we know that if f at x is now changed to f at x plus 4 over half plus 4 and half, we know that our x will change to what, x plus 4 to what. So meaning our x, remember our f at x was what, our f at x was equal to 3 over x plus 2 minus 1. So wherever we see x, we're gonna include what, f at x. So this is gonna be f at x plus 4 to the power, half, is the same as 3 over x plus 4 over half plus 2 minus 1. So this is the same as 3 over x, then 4 over, sorry, this is half, mixed fraction of 4 and a half. So we're gonna say mixed fraction of 4 and a half plus 2. It's gonna give us what, positive 13 over 2 minus 1. Therefore, you see that our p is now what, 13 over 2, and our q is what, negative 1. Therefore, we are done with 4.5. We cannot do question 5 because it's the same thing. So we move to question number 6. Oh, let's do question number 6, since it's what, an exponential function, and we're also throwing a graph here. So it's a must to do this question to know how to draw our graphs. So they say f of x is equal to what, 3 to the power of x. Whenever you hear to the power of x, just know that this is a what, exponential function. So they say determine the equation of what, the inverse of f in the form of its inverse of x, right? So we know that whenever they say the inverse of this, we're gonna what, interchange x and y. This is y, this is x. So wherever we see x, we're gonna put what, y. Where we see y, we're gonna put x. So it means we're gonna have x is equal to 3 to the power of y. So if we are here, if we get here now, we can see that this is the same as what? This is the same as our answer on question 1 there, whereby we were simplifying logarithm question, which says, it's log of x, or log of base x to base 16 is equal to what, 4. So we change this to what, 4 to be 4 to the power of x is equal to what, 16, meaning we have to take our equation sign to be to the power of what, our base. So this side we now have, this side we have x is equal to 3 to the power of y, meaning that this was what, this, we must have y is equal to something. When we have y is equal to something, we're going to have y is equal to log of 3x. This is the same as 3 to the power of y is equal to what, x. So we're going to say our graph is what, if this log of base 3x. Then we are done here. Then we go to, they say sketch the graph of f and the graph of its inverse, clearly showing all intercept with x's and the asymptote. So we are gonna use the whiteboard to solve our thing code here. We have f at x, which is equal to 3 to the power of x, and you also have inverse of f, which is the same as log of 3 base x. So this side x-intercept when you solve for x-intercept, we know that y is equal to 1, 0. So we're going to say y is equal to log of 3x. So 0 is equal to log of 3x. So this is the same as 3 to the power of 0 is equal to what? X. 1 is equal to what? X. So our first x-intercept is 1 and 0. Therefore, we're going to look for y-intercept, whereby x will be equal to 0. Then you're going to say y is equal to log of 3 multiplied by x. This will give us what? Log 3 multiplied by x. This is going to give us an error. So this is what? A new solution. So we come to this side. X-intercept, y is equal to 0. We know that y is equal to 3 to the power of x. 0 is equal to 3 to the power of x. So when we are here, we notice that this is what? No solution. Then you find our y-intercept, whereby x is equal to 0. So we're going to say y is equal to 3 to the power of what? 0. Since our x is here, so we're going to have what? Y. So we notice that this is what? 0 and 1. So we go back to our question paper by to draw our graph of f and its inverse. So this is the origin, whereby x is equal to 0, y is equal to 0. Then we'll have our 1 here. We have our 1. Then we'll have our negative 1. We have our negative 1. So the first coordinates we got are what? 0 and 1 and 0. So by 1 and 0, we're going to have 1 and 0 here. This is 1 and 0. Then again we got 0 and what? And 1. So we notice that our asymptote will be what? X is equal to 0. X is equal to x. So our graph will move like this. This is our graph of f at x. Since it doesn't have what? Any x-intercept. X-intercept is no solution. Then our graph for inverse will move like this. This is f of inverse. Then we are done with our graph there. We're going to say 6.36. Write down the equation of the line of symmetry between the two graphs you have drawn, right? The axis of symmetry is y is equal to what? X. Then we are done. Since we talked about it, say the 6.4, they say for which values of x will f at x multiplied by f inverse will be less or greater than less or equal to 0. So by this we notice that when they say it's less than 0, it's square must have what? A negative answer. So we're gonna check the graph of f, whereby we multiply graph of f and inverse, whereby is what? Is negative. So we go back to our graph. So we read graph from what? We read graph from left to right. So we're gonna start with our left hand side. We see that on our left hand side there is only what? F at x. So our graph of f is not there. We go to what? To our origin from 0 to what? To 1. We notice that from 0 to 1, our graph of f is on what? Positive y values. These are y values. These are x values. Positive what? Y values. It means our graph of f is what? It's positive. Then we check our graph of inverse, which is this side. We notice that it's on our what? Negative y values. So we're gonna say graph of f, which is positive, we're gonna multiply it by what? A negative. It's gonna be negative. Then this is the same as what? Negative, because our inverse is what? Negative. Then our f is what? Positive, meaning our first x is what? X is greater than 0 and x is also less than what? 1. So we move from 1 to what? To the x-axis, positive and infinity x-axis. We notice that our graph of f is on the positive y values, and also our graph of inverse is also on the positive y values. We're going to say positive multiplied by positive is going to give us what? A positive number. So it won't apply. So we can conclude by saying x is greater than 0 or x must be less than 1. Then we are done. Then we go to 6.4. So you write down the range of h at x is the rate to the power of x minus 4. So our range is going to be y. It's greater than what? Negative 4. Then we are done here. Then you go to 6.6. So you write down the equation of g if the graph of g is an image of the graph of f after f has been translated 2 units to the right. By 2 units to the right, it means we can say x minus 2. 2 units to the right, we minus our x with what? 2 units. Then it reflected about the x-axis, whereby we have to multiply negative 1 with y, our y. So our graph of f at x is equal to 3 to the power of x. So now that we have to find the graph of g, we have to reflect this graph to the what? Firstly we have to translate it to 2 units. So our g at x is going to be x minus 2 is equal to 3 to the power of x minus 2. And now we have to multiply our y with what? Negative. So this is the same as what? Y. We're going to multiply this by negative. So g at x, it's going to be equal to negative 3 to the power of x minus 2. Then we are done for 6.6. We move to, sorry, we move to question number 8, because we have to do calculus question so that we can wrap up. So this is what we call calculus. So on calculus, we're gonna deal with first principles and derivatives and differentiations so far. So it says given that f at x is equal to negative 2x squared plus 1, they say 8.1 says determine the first principle f at, so we have to derive f at x from what? First principle, and we know that on first principle is what? Lim as h approaches 0, we're gonna have, sorry, this is not a sign, we're gonna have f at x plus h minus f at x all divided by what? H. So this is the same as lim as h approaches 0. It's gonna have f at x plus h. It means wherever we see x, we're gonna have what? X plus h. This is the same as negative 2 into x plus h squared plus 1 minus into negative 2. Our graph of f at x, obviously we're gonna have x squared plus 1 divided by what? H. So we have to solve what? This bracket separately. We're gonna have x plus h multiplied by x plus h. Since it's to the power 2, as I said before, it means two brackets multiplying each other. So this multiplied by this is what? X squared. This multiplied by this is xh. This multiplied by this is xh. This multiplied by this is what? H squared. Meaning we're gonna have x squared plus 2xh plus h squared. So this is the same as a lim of h approaching 0, negative 2 into x squared plus 2xh plus h squared plus 1. Therefore, we have to multiply this negative with what? Our bracket. We're going to have negative times negative is going to be positive. 2x squared negative times positive is going to have what? Negative 1 divided by what? H. Therefore, we're going to say lim of h as it approaches 0, gonna have this negative 2 will multiply our bracket's gonna have negative 2x squared minus 4x h minus 2h squared plus 1 minus plus 2x squared minus 1 divided by what? H. Then you're gonna have lim of h as this approaches 0, then negative 2x squared, then 2x squared will cancel out, then 1 and negative 1 will cancel out. So we're gonna be left with negative 4xh minus 2h squared divided by what? H. So here we're gonna see that we have a common factor of what? Negative 2. We're gonna have a common factor of 2h. Lim of h as that approaches 0. We're gonna say if we take out 2 this side, and you take out h, because we have 2 here, we have 2. Then here we're gonna be left with what? Negative 2x. Then this side we're gonna have what? Negative h divided by h. So this is the same as lim. As h approaches 0, our h will cancel this h. We're gonna have 2 into negative 2x minus h. So when they say h approaches 0, it means we'll have 2 into negative 2x minus 0. Wherever we see h, we put what? 0. So this is the same as 2 into negative 2x, which is equal to negative 4x. Then we are done with 8.1.1. So they say hence means from what you got from our previous answer. Hence, from what you got, calculate the gradient of the tangent of f at x is equal to what? X is equal to negative 4. We know that the first derivative is equal to what? Gradient of a tangent, remember. So we're going to have f at x is equal to what? Negative 4x is our first derivative. So we're going to say f at negative half is equal to negative 4 into negative half. So we're going to say negative 4 multiplied by negative half is going to be what? Positive 2. So yeah, we are done, meaning that m is equal to what? 2. Then we move to 8.2. Take that. Determine the derivative of what? Of f at x. If it's given that the cube root of x squared plus 1 over 4 x to the power 4. So firstly, we're gonna simplify by changing our root here, then simplifying this side also. So here we're gonna have x to the power of 2 multiplied by 1 over 3. If we remove our cube root, we're gonna remove it by what? 1 over 3 plus 1 over 4. We have to take this x to the power of 2 of 4 to be what? X to the power of what? Negative 4. We multiply it by what? Our 1 over 4. Therefore, f at x is the same as x 2 over 3 plus 1 over 4 multiplied by x to the power of negative 4. So when we derive, we're gonna say the exponent will multiply what? The coefficient of x, which we're gonna have 2 over 3 multiplied by 1 is gonna be what? 2 over 3 x to the power of, then x we're gonna minus our exponent by 1, which is gonna be 2 over 3 minus 1. We'll have negative 1 over 3. Therefore, we come this side, you're gonna have negative 4 multiplied by 4, 1 over 4. You're gonna have negative 4 multiplied by 1 over 4. Make sure that you press your calculator correctly. It's gonna give us what? Negative 1 multiplied by x. Remember, here we have to minus by what? By 1, meaning we'll have what? Negative 5. So this is the same as 2 over 3. We can now change our x to be what? Positive by saying x to the power of 1 over 3. Then minus 1, we can change our x to be positive by what? Divided by what? X to the power of 5. Therefore, the first derivative is going to be what? 2 over 3 x to the power 1 over 3 minus 1 over x to the power of 5. Then we are done here. Then it says 8.3. It says h at x is equal to ax squared, whereby a must be greater than what? Than 0. Not equal, not greater or equal to, must be greater than what? 0. Which means it's gonna be from 1 until the infinity. So they say determine the value of a if it is given that the inverse of this graph is of a is equal to the first derivative of what? Of 4. So firstly we have to find what? The inverse. So we're gonna have h at x is equal to ax squared. So when you find the inverse, we interchange x and y to be what? X is equal to a y squared So this we have to make y the subject of the formula by dividing what by a. Therefore, we have x over a is equal to y squared. So if we want to remove squared here, we will introduce what a root. So we're gonna have y is equal to root of x over a. Then we have to solve what our first derivative. First derivative is gonna be what 2 multiplied by a. It's gonna be 2a x. Then we say 2 minus 1. It's gonna be what 1. Therefore, we are done. We can now solve our a. Remember, they say this is equal to what to this, meaning that wherever we see x, we can put what 8. Wherever we see x this side, we can put what 4. Therefore, we can say root of. Remember, this is the same as h. This is the same as h of what negative x. So we're gonna say 8 over a is equal to what 2a into 4. So this is the same as root of 8 over a is equal to 2 multiplied by 4. It's gonna be us 8a. So we have to remove this root by what? By squaring both sides. This is the same as 8 over a is equal to 8 to the power of 2. 8 to the power of 2 is gonna be 64. Then 8 to the power of 2 is gonna be a squared. Therefore, we will have to divide. We will have to multiply our to do a cross multiplication, which means 8 is going to be multiplied by 1. It's going to be 8 is equal to then 64. A squared will be multiplied by what? By 8. This side will have 64. 8 to the power of 3, then 8. Then we have to divide by what? 64, because we're looking for a, not 64a. So we're going to have 8 divided by 64, which is gonna be 1 over 8 is equal to what? A to the power of 3. So when you're looking for a, we know that we have to do what? We have to multiply our exponent by what? What? Its inverse. Also this side we have to multiply by what? 1 over 3. So a, this and this will cancel. So we're gonna have a is equal to 1 over 8 to the power 1 over 3, which is gonna give us what? Positive half. Therefore, we are done. So far, we have covered calculus, we have covered our exponential functions, we have covered functions, we have covered number pattern, and we did algebra. So I think the lesson is done for today. So thank you for watching this video and subscribe.